Hello guys, so far we have done speed and velocity, we have seen displacement. So distance and displacement, speed and velocity. Now let's move a little further and we'll start with acceleration now. Okay, now what is acceleration? If velocity of a body changes, then we say the body is accelerating. Okay, that means a body starts from rest, okay, starts moving, and the velocity keeps on increasing. Let us say after some time the velocity attains some maximum value, and then again it starts decreasing. Okay, and finally the body again comes to rest. Okay, so over here the velocity is continuously changing. I can give another example of a body which is thrown vertically upwards. Okay, I throw a ball vertically upwards. What happens to that? As it moves up, okay, its initial velocity has got maximum value. Okay, then as it starts moving up, the velocity goes on decreasing because gravity is pulling it down. At some point of time, at the maximum height position, the velocity at that point it becomes 0, and now it will start again falling down. Now, as it starts falling down, then the velocity goes on increasing, and finally when it reaches ground, the velocity will be again it should be equal to what it was initially. Okay, now here I am ignoring air resistance and all those forces. Okay, but in this case the important thing is the velocity keeps on changing. So whenever velocity keeps on changing, we say that the body is performing accelerated motion. Okay, so like we define velocity as rate of change of displacement, we define acceleration as rate of change of velocity. Okay, so acceleration is the rate of change of velocity. Okay, so that means my acceleration, it is equal to change in velocity divided by time. We had defined velocity as rate of change of displacement. We had defined velocity as this: velocity is equal to ds by dt. So now I am defining acceleration as rate of change of velocity. So I would call this as dv by dt, correct? Derivative. Again I am using some calculus, some basic calculus here. For these fundamentals in calculus, refer to my calculus in physics videos. I am mentioning that link in the description here. Okay, so it is again d dt of ds by dt. So I would say acceleration is my second derivative of displacement with respect to time. Okay, so that is how we write acceleration. Okay, in speed and in velocity we had some types like this. One is uniform velocity, and then variable velocity, then average velocity, and instantaneous velocity. Likewise, we are going to have uniform acceleration, then variable acceleration, then what is the next one? It is average acceleration, and instantaneous. Now what is uniform acceleration? If in equal intervals of time my velocity increases or decreases by equal amounts, okay, then I call it uniform acceleration. If in equal intervals of time my velocity changes by different amounts, then I call it variable acceleration. Okay, now average acceleration. velocity of the body is changing, okay, and it is not uniform, it is variable, okay, but then I should know what is the average acceleration. So for that, what do? I start from, I note my velocity at t is equal to t1, it is, let us say, v1, okay, and then at t is equal to t2, I note the velocity again, and that is v2, okay. So what is the time taken? My time taken is t2 minus t1, and what is my change in velocity? Is it not v2 minus v1? So my average acceleration would be equal to v2 minus v1 upon t2 minus t1. So it is basically delta v upon delta t, okay. Now for instantaneous acceleration, like we discussed for speed and velocity, here my instantaneous acceleration would be the acceleration at that particular instant. And for that, what we will do is we will define this as delta v upon delta t, okay. And then again, instead of just writing delta v upon delta t, I'll take its limit as delta t tends to 0. Delta t approaches 0, delta t is very small, infinitesimally small, and delta v is a corresponding infinitesimal change in velocity, okay. And then that will give me my instantaneous acceleration, correct. So these are the 4 types of accelerations that we are going to come across, okay. Now coming to whether it is positive or negative. Acceleration is rate of change of velocity, okay, and velocity is a vector quantity, isn't it? So obviously my acceleration will be a vector quantity. Now again, acceleration is a vector quantity, that means it can be positive or negative, correct. So if the velocity of the particle performing this linear motion, okay, or motion we will say, if the velocity goes on increasing, that means my v2 minus v1, final velocity minus initial velocity, is going to be a positive quantity, isn't it? So obviously my acceleration would be positive. I'm going to write positive . On the other hand, if my velocity goes on increasing over time, right, so that means my v2 minus v1, final velocity minus initial velocity, that quantity is going to be negative, because my velocity is going on decreasing, so final velocity is smaller than my initial velocity, isn't it? So that quantity is negative, so obviously I am going to get negative . So in short, I have 1, 2, 3 and 4, and then these are generally going to be the types of accelerations that we are going to have. And alright, now here I think we should do some numerical problems, okay. These numerical problems will be done in the next video, and after that we would be switching to something called kinematical equations of motion for uniform acceleration. Thanks so much.